To solve for a variable means to write an equivalent equation with that variable alone on one side of the equation. In this first problem, we have the simple interest formula, I is equal to P times R times T, and the instructions are asking us to solve for T. At first glance, this may be intimidating because of all the variables. However, if you think of a problem like 12 is equal to 4x, where we have something equal to something times our variable and are solving for x, we undo that multiplication with division, and because they are numbers, we can put an equivalent substitution value and cancel out common factors to come up with a solution. This is the same thing that we're going to do on this problem. What's happening to t? It's being multiplied by. To undo multiplication, divide by that quantity. To maintain equality, we'll divide both sides. Because these are variables and we don't know the value, we'll leave them as is. Canceling out common factors leaves us with 1 times t, and t, our solution. This next example has the perimeter of a rectangle. The perimeter is equal to twice the width plus twice the length, and the problem is asking us to solve for w. Again, there's more variables than numbers, which may be somewhat troublesome, but let me show you a similar problem that you have been solving, where we have more things being done to the variable than just one operation. In this example that I wrote down, to get the variable by itself, first thing we would do is subtract 6 from each side, and then undo the multiplication to get the variable by itself, and simplify. Because we're working with mainly integers, we have the variable by itself. Similar procedure here. What's happening to 2w? It's being increased by 2l, so to undo that addition, we'll subtract, and to maintain equality, we'll do that to both sides. These are not similar terms, so they just get written as is, leaving the 2w by itself since the 2l's are gone. Now, to get w by itself with a coefficient of 1, undo multiplication with division, and what we do to one side, we do to the other. And here is our solution to this problem. Now you may see those 2's in the numerator and denominator that perhaps can be canceled. The only way that we can cancel those is if we pull this numerator over the common denominator into 2 fractions with the common denominator. So this expression is equivalent to p over 2 minus 2l over 2. Then, and only then, can we cancel out the common 2 in that second fraction. So another version of an equivalent solution for w would be p over 2 minus l is equal to w. In this example, they're asking us to solve for pi given the formula for the area of a circle. When we use the equation solving procedure, the first step is to eliminate fractions. And the same thing is applicable here. Any equation with a fraction always appears to be more difficult, but we have only one denominator, it's 4. I'm going to multiply both sides of the equation by 4. On the left, this expression cannot be simplified, but on the right, because there is a common factor of 4 in the numerator and the denominator, they cancel out, leaving a 1, and 1 times pi d squared is what we have on the right. To get pi by itself, the last operation is to divide both sides by d squared. And again, because we don't have values for these variables, there's nothing to simplify. On the right, the d squareds cancel out, leaving pi, our solution.